Oh,
Okay, so yeah, so that's the basic idea.
right.
Right? So the other ones are similar.
Can you do one natural log question, the F1? Last.
Yeah, so this one, natural log means the base is e,
Yeah.
right? So we just follow what we did here, right? So when you write out, it's the base raised to this power, so
And then
e to
result.
the second power is equal to x. And okay, so now because the numbers is e, right? Because the base is e, now you have to use the calculator to calculate. So
2.187.
it's e raised to the second power,
Mm-hmm.
right? So you can use the exponential function key here, right? E to the x. So I just do e to the x. And then you just need to enter in the power now, right? It's raised to the second power. So I raise it to the second power, and so I get 7.389.
So that's our X.
Yeah, so that would be x. Okay, so this you need to use the calculator for. Yeah, so basically, once you have it into exponential form, that'll tell you what you have to calculate it. So d is a little bit different, right? Because all the other ones, the x is in this place, so those are exactly the same. But this one, x is now in the base. Uh, but you started off in the same way, right? So just write it out. The base raised to this power
Mm-hmm.
equal to is equal
32.
to this thing, which is 32. And then okay, so now you don't get x for free, right? Because before it tells you exactly how to calculate x. Right,
Yeah, 1 by 5.
now I need to solve for x. So how can I solve for x?
1 by 5.
Right, so you raise it to the reciprocal power, right? So it's raised to the 1/5 power. So you get
So
x is 32 to the 1/5 power. And so 32 raised to the 1/5 power is equal to 2.
yeah.
Okay, so those are those problems.
Mm-hmm.
Um,
All right.
yeah, C and E are basically
Same.
the,
Yeah.
the same as B, right? This one means the base is 10 when it's not written in. And this one is okay. So those are like that. Um, example 4. I mean, it's kind of the same, but it's also now a little bit different, right? Because so now you're trying to calculate this thing, but you don't know what the exponent is now this time.
Mm.
Right, so that's what's missing. But you still started off the same way, right? So you switch it to exponential form and just write it out, right? So it's this when you write out this raised to this is equal to this, right? So it's 3 to the x power is equal to 1/27.
Mm-hmm.
And the method of figuring out what x is now is is called matching the base.
Mm-hmm.
Right, so I want to write 1/27 in terms of base 3.
Right.
So you sort of think of how to do that, right? So the number 27 is in the denominator, and you want to think in terms of base 3, right? So you just try to calculate some exponents
Right.
one at a time, right? So 3 to the first power would be 3,
Mm-hmm.
and then 3 to the second power
9.
would be 9, and then 3 to the third power would give you 27.
27. Yeah.
right? So that's where the 27 is coming from, is 3 to the third power, except it's in the denominator. Right? So when things are in the denominator, that means it has a negative exponent.
Hmm.
Right? So you can write as 3 to the minus 3.
Yeah.
And so when it's written out like this, once the bases are matched, then the exponents have to be the same, right? So then it tells you that this x has to be the same as -3 until x is -3. So that's the
Okay.
basic idea.
Right.
Like for B, right? So you start off the same way. Right? So the base raised to this thing is equal to this thing. Is a 6 to the x is equal to square root of 6. Now I want to match base, right? So square root of 6,
Is
how can I write it as a power of 6?
1/2?
Right, so you have to remember that square root is the same thing as a 1/2 power.
Yeah. So that
So,
means it's 1/2. X equals 1/2.
right, so now when the bases are the same, that means that this and this has to be the same. So x has to be 1/2.
Okay. Right. And then we always have to find the exponents or some
No,
any.
it depends on what's missing. Right.
Right.
So in the previous problem, the x was located here,
Mm-hmm.
and then this one, the x is in the base, and then
Yeah.
this one, the x is where the exponent should be. So it depends on what's
Situation.
missing in the equation.
Okay. Can you do E?
Yeah. So that's when you have different bases like this. You can follow
Right.
in the situation where it's either the common log or the natural log.
Mm-hmm.
It's actually even more straightforward than that. I mean, you can follow what we did in, like,
We
say,
can
A or
use
B,
calculator.
right? So like say if you write it out like this, right? So it'll be 10 to the x is equal to 1000, right? So you ask yourself, 10 raised to what power is 1000?
Uh,
So
10, 10, 10,
like,
100,
if it's
sir.
1, then you get 10. If it's 2, then you get 100. If it's 3,
Uh,
then you get 1000, right? So x would have to be 3.
3. Okay.
Uh, However, there's an even easier way to do it, right? Because the calculator has the common log,
Mm-hmm.
right? So what am I calculating? The log of
1000
1000.
is 3.
So, right, so because it's the common log, I mean, the calculator can calculate it for you.
Okay.
Right? So
So in the exam, can we write it like that? Like straight away if we get the question, some question like that?
yeah, you can.
Okay.
Right? So like the next one, right? So say you want to calculate the log of 1
1 band.
over 100, right? So you just put into the calculator exactly
Mhm.
as you see it. And what do I get? -2, right? So
Right.
it should be -2.
Okay.
Even for the natural log, right? So you would just use the natural log key instead. Right? So natural log of what is it? E to the 1/5, right? So E to the 1/5, and close parentheses. You get 0.2. 0.2 is the same thing as 1/5.
Okay.
And I mean, so there's several ways to think of this, right? So as I said before, the log and exponentiation are inverses to each other, right? So when the base of the log matches the base of the exponential, because they're inverse to each other, they should cancel out. And that's why the answer is exactly just 1/5.
Okay.
And the same thing happens to C also, right? So the base of the log here is the same as the base of the exponential. And so they cancel out, and the answer is 1/4.
Okay.
And it's actually the same true in I also, except it's just in the reverse order. The base of the exponential is the same as the base of the log here, so they cancel out, and so the answer is square root of 3.
Okay.
Uh, okay, so any questions on
No.
working with logarithms?
No. It would arise when I'll do the practice. Then I'll send you the request on my open math.
Okay.
Yeah.
I've actually also included 6.5
Yes.
for if you want to go over that also.
Yes. Yes.
Okay, so yeah, so this is 6.3.
Right.
Then the problems here are fairly straightforward.
Mhm.
6.5 is actually not too bad either. It's also fairly straightforward.
Yeah.
Hey, Professor. Will you be putting up the link, or have you already put up the link for 325 and this on Office 365?
What link?
The link to the meeting for 325 and or the previous one and this meeting right now.
They're already up.
Oh, on 365. On Office 365, right?
No, they're on the Canvas page.
Okay. On under the files or the discussions tab?
They're on the main page. Right, if you go into the all the links for everything are on the main Canvas page.
Okay, but not the recorded meetings that we're having right now.
They are, but some of them I don't remember to record until like halfway through the meeting. Right? So
Oh,
like today I didn't record until like 20 minutes ago or something.
oh
So
wow.
it's
Okay.
missing the first half.
Okay. And you didn't, were you able to record the meeting on 325 and then again on I guess
Yeah,
it was last meeting, I think.
yeah. Online class meeting 325
Okay,
on
perfect.
section 5.6. Online class meeting
Uh-huh.
323 on 5.2 and 5.3.
Okay,
But
and this is
even on the sections that don't have a meeting, right? So all the sections have videos associated to it. So like what I'm discussing now, section 6.1 has videos for that section. Section 6.3 has videos for that section. And section 6.5 has videos for that section. Right? So
okay.
uh
So whatever, regardless of whatever we're going through in the meetings, it's the videos for those materials already up. You're saying, okay, got it.
yes.
All right. And just one last question. The meeting on the 30th, did you record that or
Uh I did it. Yeah, no, I don't think I recorded that one.
not? Okay. All right. It doesn't matter. If I have any questions, I'll just ask you. I'm sorry. You can continue on. Thank you so much.
But in some of the meetings, I don't even go over the sections. It depends on who is at the meeting and if they ask questions, specific questions.
Okay. That's why you're telling me about the links. Okay.
Yeah. So
Gotcha.
I mean, if you have any specific questions, I can answer them now.
Yeah. Right now, I don't. What I'm doing is I'm just recording the meeting, so that way, whoever did have any questions, a lot of my questions have already been answered because of other classmates asking you. So if I have any questions, it'll probably be like, very minimal questions, very minimal detailed questions. So I'll just ask you through email or something.
Okay.
Yeah, thank you so much.
Yeah, but all the content is on Canvas.
Yes, sir.
Right, so you can just go into Canvas and review the materials from there.
Okay. And have you decided anything on the exams or anything? The next tests, what will come out of it?
Yeah, the next test will cover chapters 5 and 6, and
Okay.
it's going to be there's going to be 2 parts of the test. So the questions will be done through My Open Math. So the questions going to be set up in My Open Math. I'm going to ask you to write down your work and submit your work through Canvas also.
Okay. And do you know what the date is going to be for that exam?
It's going to be sometime towards the end of next week.
Ooh, okay. All right. And is there going to be like what Rutgers is doing, like a proctor type exam where we're going to have like a webcam or we're going to have to be in front of a camera?
No.
Okay. So there's a time limit on the exam?
Yes.
Okay. And it'll be like the 2 hours that we have for class, I'm guessing.
I haven't decided on the time limit yet.
Okay, but you'll give us details whenever for the exam, whenever you're.
Yes.
Okay, gotcha. Perfect. Okay. Let me see. Oh, is there anybody else that's on right now or no?
Yeah, there's one other person, 2 other people maybe.
I'll try. One second.
6.5.
Yeah.
Sorry.
Yeah. So section 6.5 is on the different rules for logarithms, and they're essentially the counterparts for exponents, right? So, like say for exponents, if you have x to the 3rd times x to the 6th, right? So you can combine them, right? And what is the rule for combining the exponents?
Adding them?
Yeah, you add them here, right? So 3 plus 6 will give you 9.
Okay.
Right, so that's the rule for exponents here. So basically, what this rule is, it changes multiplication into addition.
Okay.
And so the counterpart for logarithms sort of follows the same idea. You just have to be aware of which operations they are and where they occur, right? So, like what's going on here, you have the multiplication outside of the 2 things, and then the addition occurs inside the exponent, right? So the 3 plus the 6 gives you 9. So the way it works for logarithms is the multiplication now has to occur inside the logarithm, and then you write the addition outside of the logarithm. It's essentially the opposite, right? Because multiplication outside, addition inside, whereas here now it's multiplication inside, addition outside. Because logs and exponentials are inverse to each other.
Mhm.
Right? So,
So how are we going to write the x cube into x6 while combining?
Well, okay, so when you're applying the rule for logs, there's going to be two ways you apply it. So either you're given a single log and you're asked to expand it into separate logs, or you're
Okay.
given separate logs and you combine it into a single log. But again, you're just paying attention to how you should do the operations,
Okay.
right? So, again, the multiplication should be inside, and the addition should be outside.
Outside. Okay.
So there are a lot of similar things where you're not allowed to apply this rule, right? So when the addition is inside the logarithm, the rule does not apply, right? So you cannot simplify this. And similarly,
Okay.
if multiplication is like this, again, it doesn't follow the rule, and so you can't do anything here either. So be careful.
Okay.
It's kind of like how if you have x to the third plus x to the fifth, right? You're not allowed to combine this because they're not like terms, right? It's the same thing for logs. If it's not in the right form, you can't use the rule.
Okay.
Okay, so this example is already written out, but it basically just follows the rule, right? So again, you use it in two ways. So if you're expanding, right? So you have you're expanding the log, right? So the multiplication is inside the log, and it changes to hold on. If you're not speaking, can you mute? Okay, so yeah, so the multiplication is inside. Right, so it changes to addition outside. And you write out the logs separately with the same base, right? So here's base 7. So each of the logs has base 7. And then you separate the two factors, right? So the x plus 3 and the x minus 3 is what's being multiplied, right? So they appear in the separate logs. And then, so that's when you expand. And then when you combine it, it's in the reverse direction, right? So the addition outside the log changes to multiplication. And the logs combine into a single log, right? So it's the natural log, so I use the natural log. And then each of these things, because they're being added, in turn goes all inside the single log, and then they're being multiplied together. Okay, so that's the sum rule. And so there's two more rules, the difference rule and the power rule. And so they they follow the same idea, right? So the difference rule is the same thing, except it's between division and subtraction, right? So similar to how if you have x to the fifth over x cubed, then the rule here is to do 5 minus 3 to get 2, right? So this is the counterpart for logs, where it changes division to subtraction. Right? So if you have division inside this log, then it expands to subtraction, or you can take subtraction and then combine it using division. So that's the difference rule. And again, be careful where the operations occur, right? So if you have subtraction inside, you can't do anything here. You're not allowed to separate, and if the division is outside, you're not allowed to combine, right? So be careful about how you apply the rule. Make sure it looks like it's the correct form. And then finally, we have the power rule. Well, technically, there's one more on the last page here, but the next one is called the power rule, and the way it works is the exponent inside the log turns into a coefficient, right? So it becomes multiplication outside the log, and then vice versa. Coefficients turns into exponents. So that's the power rule. Okay, so are there any questions?
No, that's fine.
Okay, so those are the three rules. I mean, so they're written out separately, but in most situations, you'll be asked to use all three rules together. So again, you just have to pay attention to where the operations are and what they occur, where they occur. Right. So I've explained it sort of in this page here, what you're looking for. Right. So if you're combining logs, first make sure that all the logs have the same base. This one is pointing at the wrong thing. The base should be here. And I mean, so you can see that this has subtraction and addition together. Right?
Can you zoom a little bit more? Okay.
So this one has, you can see that has subtraction and addition together. Right? So things that are added are multiplied and things that are subtracted are divided. Right? So you can think of it in the following way when you're trying to combine. Right? So you look at terms that are subtracted should go in the denominator, and then terms that are added go into the numerator. Right? So I mean, there's no sign in front of this, but you can automatically think that's a plus, right? Because it's positive. Right? So the log for the x is being added and the log for the y is being added. Right? So when you combine them, that should be multiplied in the numerator. Right? So that's why I have the x times y in the numerator. And then the 2x cubed, that log is being subtracted. So subtraction turns to division. Right? So that's why terms that are being subtracted go into the denominator. So the 2x cubed goes into the denominator. And then finally, when combining, coefficients become powers, right? So the log for x has a coefficient of 2. So this coefficient turns into a power for x. Right? So that's written here. This doesn't have anything, right? So I don't put any power here. And then the y has a coefficient of 4, so that turns into y to the 4th here. Okay, so you just put it together piece by piece according to this thing, and then you have an x on top and an x on the bottom here, right? So you can simplify that. So that's what's going on in this example. So these are the things to pay attention to when combining logs, and when you're trying to expand logs, you just work backwards, right? So so you make sure all the logs are the same. So this one, they're all natural logs, and you look at how many pieces you have. That'll tell you how many terms you have, right? So I have x, y, w, and z. So 4 variables. So that's why I have the 4 terms here. And you want to be careful about what should be added and what should be subtracted, right? So you want to follow the rule that the factors that are on top are terms that should be added, and any factors that are on the bottom are terms that are subtracted, right? So you see how the w and the z are on the bottom here, so they turn into subtraction, The reason I want you to be careful about that is because here you see how W and Z are being multiplied. Even though there's a multiplication here, when you separate them, it still turns into subtraction. The reason is because the Z, because the Z is in the denominator, ultimately is being divided. Right? So the X and Y are dividing the Z, and that's why it needs to be a subtraction here.
Okay.
Okay, so that's what you want to pay attention to. But then the rest is just working backwards, right? So in this case, exponents turn into coefficients, right? So y has exponent 1, so there's a 1 here. This has power 2, so this has coefficient 2. These are 3 and 4, so there's a 3 and 4 here. Okay, so that's how you want to apply the rules. Okay, so like, for example, in this example here, we want to combine it into a single log, right? So it's log base 5. So this is a single log, and I want to put everything. It's not writing. Okay. I think the battery is running low. Okay, so you put it into a single log, and what should go inside the log? So I have an x and an x plus 1.
It's going to be.
And then the operation here is addition. So how does addition change? It changes to multiplication.
Okay.
Okay, so that goes there and there, and then the coefficients. And then let me use a different color. What should I do for the coefficients? What did I use before? Green? No, purple. So what should I do for the coefficients? The coefficient 2 was for the x. So coefficients turn to powers, right? So this 2 goes here, and this 7 is the power for x plus 1. So that goes here. Okay, so that's combining, and expanding. You just try to work in reverse, right? So second example here, I have the natural log, and you count how many you have. You have x, y, and z, so I should have 3 terms.
Yes. And
then, right, so the variables are being separated, right? So you have ln of x, ln of y, and ln of z.
3 ln x plus 1 y plus 6, and then minus.
Yep, so minus 5 ln's. Yep.
Yes.
Just like that.
Okay. Right.
Yeah, so that's how you want to apply the rules. So the next page is just some more examples of applying those rules. So I guess I can skip that for now. I mean, it's in the video, the other video, to look over that.
Okay.
The I guess the last new thing is on the last page.
Right.
Which is the change of base formula.
Okay.
This is actually very important, right? Because before, I mean, if you have, like, say, the common log of 32 or something, this is okay, right? Because this is exactly something you can put into the calculator and calculate. Like, I mean, log of 32, you just enter it in exactly like that, right? Because it's base 10. And then same thing with the natural log, right? So natural logs, if you're asked to calculate natural logs of things, so like say natural log of 2, you can just calculate, you can just put into the calculator, right? But what about say log base 2 of 7 or something if you're asked to calculate this, right? So now this is more complicated because the calculator doesn't have log base 2, right? So the change of base formula allows you to calculate other logs using your calculator, and so that's why the calculator only has the common logarithm and or the natural logarithm, because even if you have a different base, you can still calculate them using those two functions, and that's where the change of base formula comes from. So you can use either the natural log or the common log. They both give the same answer. I prefer to just use the natural log because it's more natural, right? So yeah.
Wait. So the ln and the log, they're just the same thing.
No, they're not the same. Right. So like say I want to calculate the log of 32 and the ln of 32, right? So these two separate calculations, they give you different numbers, right? So log of 32 was 1.5 something, and ln of 32 will give you a different number, right? It's 3 point something, right? So so they're not the same operation because they have different bases. What I'm saying is when you're using them as part of the change of base formula, then they give the same answer.
Okay.
When you're using it in this, then it's the same answer. But if you're just calculating them individually, they're two different things.
Yeah.
Okay, so how does the change of base formula work? Right, so you just take these two things. The number that appears here goes on top, so it's natural log on top, and then the number that you see here, you calculate as the natural log on the bottom. Right, so like in this example here, where I'm asking you to calculate log base 8 of 32. Again, I prefer to use the natural log, but so when you write it out, right, so the number that appears here, you calculate the natural log on top, and then the number that appears on the bottom, you calculate the natural log on the bottom. Right? And so when you punch it into the calculator,
Okay.
natural log of 32 divided by natural log of 8, there's a 1.66. So I only wrote down the natural log on the paper, right? But let's do the same thing with the common log, right? So if I apply the formula with the common log, right? So
it's gonna be different.
Log of 32
Oh no, it's not gonna be different. It's not gonna be different.
Over log of 8, you'll see it comes out to be the same thing.
Mm-hmm.
Even though individually log of 2 is different from natural log of 32, and log of 8 is different from natural log of 8. When you put them together, it's the same.
Okay.
So when you're using the change of base, it doesn't matter which of these two you use.
But if it was, what if it was an expression that had a log, a natural log, and a common log? Then it needs to be, what do you call it? It needs to be separated, right? If there's an expression with the common and the natural log.
I don't think you'll. I mean, at least in this class, you won't see one like that.
Oh, okay.
Because then it becomes much more complicated. Yeah, so like any kind of equation, typically the logs will have the same base, so you're not going to mix them together.
Okay.
Okay, so the examples here are just asking you to practice using this formula, right? So again, to use the formula, you just have to remember the number that appears here, you do the log on top, and then the number that appears here, you do the log on the bottom, right? So this would be natural log of 1 over the natural log of 3. then you put into your calculator, you see that this is 0. Right. Well, I mean, yeah, I mean, it calculates to 0, but also the reason is because, as I said before, no matter what the base is, the log of 1 is always going to be 0. But the next one, just follow the formula, right? So you do natural log on top. This you do the log on the bottom. And so writing it out is natural log of 24 over natural log of 6. And then just enter it into the calculator just like that. So you get 1.7737. Okay, so that's the basic idea behind the change of base formula. So are there any questions?
No. Because you were doing natural log. I mean, it could be log, right? It could be a common log.
Yeah, it doesn't matter which of them you use.
Okay.
Like say this one, if I use the common log instead, right? So common log of the regular log of 24 divided by the regular log of 6. You can see it comes out to be exactly the same thing.
Right. Okay.
Right, so when you're using the change of base, it doesn't matter which one you use.
Okay.
Professor, if the denominator holds a value of 1, then we can't automatically assume that the product will be a 0, right? Then it's not the same thing as the log of 1 being in the numerator on top.
Yeah, it's 0 only when the 1 is here.
Okay. Yeah. So if it's attached to the log, then we have to evaluate it and finish it out. Okay.
Yeah, but you're never gonna see the 1 here, because then it doesn't make sense at all. So
Okay.
you'll see any number except 1.
Okay.
Yeah. So
is that like calc 1 or something?
no, it just doesn't exist.
Okay.
Because it doesn't make sense at all.
Log 1 doesn't exist in. Okay.
So yeah, so the 1 can only appear here.
Gotcha. So then that's 10 divided by 3.
Yeah, this one would just be log of 10
by 3.
Log of 3.
Professor, what is mantissa?
Mantissa?
Yes.
I've heard it before. It's the technical term for something, but I don't remember what it's for.
It's used in logarithms.
Hold on, it's probably just one of the parts of the logarithm. I don't really use the term, so I don't remember what it's for.
Right.
Uh,
So are we going to study the laws of just these 4 laws, or other laws of logarithms, or other forms of logarithms like natural logarithms or law of product law, quotient law? No, we did.
yeah, the product, the I called it the sum rule and the difference rule, but you can also think of it as the product and quotient, right?
Okay.
Because the sum deals with multiplication,
Right.
and the difference deals with the division. So
Okay.
it's just a different way of calling the rule, but
Right.
they're the same rule.
Okay. And then we have. So we're done with 6.5 and 6.6 is left, or
Yeah, we'll go over 6.6 next Monday.
okay, right.
Okay.
But yeah, so I mean, I'll post this video onto, and so everything is listed on the main Canvas page, right? So so this will be posted, but in any case, any of the topics that are cut off, just go into the section videos, right? So I don't remember where I started recording, but like if say if you need to go over section 6.1, right? So yeah, we talked about this at the beginning of class, but like the so this page on the 6.1 worksheet is discussed in this video.
Well, you have a YouTube channel?
So it's compound. Yeah, I have to upload the video somewhere. So
That's awesome. Just kidding.
yeah, so just go into the section videos to review the specific sections.
Okay. What do you call it? I'll wait till the other student is done asking questions, and I'll ask my question.
I'm done. You can ask.
Okay. What do you call it? Professor, you remember my email. So when you said I don't know if you want to wait till she logs off to talk about that, or if it's okay to just talk about it right now.
No, I can talk to you in private if
Okay.
you
Yeah.
prefer. After I close this meeting.
Okay. Okay, gotcha. Perfect.
Okay. Are there any other questions?
No. Yeah. Everything is fine. Yeah. No questions.
Okay. So yeah. So I mean, as you work on the MyOpen Math problems, if you have any questions, just either contact me through the team chat or send me an email.
Right. Okay. Perfect.
Yeah, and once I have the test all figured out and set up, I'll email everyone the details on that.
Sure. Right. And it's going to be next week after Wednesday, right?
Yeah.
Right. And we have time on Wednesday to discuss about the tests and questions about chapter 5 and 6.
Yeah. So like Wednesday, if you have questions before the test, you can ask me next Wednesday.
Right. Okay. Perfect. Right. Thank you very much, Professor. Bye-bye.
Okay. Good night.
Good night.
Do you want to just, what do you call it? You said you're gonna call me?
Yeah, I'm gonna stop recording and then set up a private meeting.
Okay.